here's the incline, right? In number 9, we have a box on an incline. So here's a box on an incline. If I put it on there, it slides down. So what does that mean? There's not enough what? What kind? To not slide, right? There's not enough static friction, right? So it slides down. So if I don't want it to slide down, what I could do is I could put it there and I could hold it up. So that means I'm pulling force up, or I could push it up. So I'm pushing it up, or I could push down on it. And when I push down on it, I now have enough static friction. But I'm not applying a force that way. I'm applying a force that way. And by doing that, what do I change? The normal force, right? Now the normal force increases, which increases the static friction. And so it can stay there. So that's what we're going to look at in number 9 here. All right, so number 9, we have our incline, which is, I think it's 35. Yeah, 35 degree. And sitting on there, we have a 3 kilogram box. So that means that Fg is 29.4 newtons. And what we want to do is resolve those. So we got Fgy is 24.1 newtons, and Fgx is 16.9 newtons. Now that we have those, we can complete our free body diagram. Here we have our normal force, 24.1, and Fgx, 16.9 newtons. So if I want that block to stay at equilibrium, if I want it to stay at rest, how much static friction do I need? Right, I need to have a static friction equal to 16.9 newtons. Now the problem is that there's not enough static friction, because if we calculate what is the actual static friction given the coefficient and the normal force, the coefficient is 0.3 and the normal force is 24.1, we get 7.2. So in that situation, we only are able to have 7.2 newtons of static friction. So I need to do something to increase that. Now problem 9 tells us I'm actually going to apply a force downward, and by doing that I'm going to increase the normal force, which then allows the static friction to go up. So the question is, to get to 16.9 newtons of static friction, so let's, right here, right in blue, I want to change this to be 16.9 newtons. So let's look at our static friction again. If static friction is to be 16.9 and the coefficient remains the same, what normal force do I need? So I'm going to solve for that, and I get 56.3 newtons. So that's the normal force I want. So I don't want 24.1, I actually want to make it larger and make my normal force 56.3. When I do that, I'll have enough static friction. So in order to do that, I need to add a certain amount of force to this y component. So the amount of force I need to add is the difference between 56.3 and 24.1. So 56.3 minus 24.1 is 32.2 newtons. So that means what I need to do is push down with 32.2 newtons of force. So then 32.2 plus 24.1 gives me the 56.3, which then allows me to get 16.9 newtons of friction.